So for example C, the first question says, which student's data is the most accurate? If we're asking which is the most accurate, that means which student's data is closest to the actual measurement for the real density of sucrose. So closest to 1.59. So who is closest?
Student A.
Student A, because their average was this, 1.57. That's closest to 1.59. So student A. What about most precise? That means whose measurements are closest to each other? C. Student C had the least amount of variability, so I would say student C. Exactly. Not very much variability in their measurements. And then finally, calculate the percent error for the least accurate student. So least accurate student means whose data, whose measurements are further away from the real thing, or furthest away. Student A, B, or C? So we're using student C's average. Shh. Please stop talking.
I'm sorry.
We're using student C's average measurement. So the average would be this one, and it's going to be that. So 1.70 is student C's average, and the real value is 1.59. So I do 1.59 minus 1.70 divided by what? 1.59. We then put the absolute value things around it, and we'll end up multiplying by 100. When you plug this into your calculator, it's going to be 1.59 minus 1.70. Hit enter, and then divide by 1.59. And then multiply by 100. When you do that, it puts it into the percentage formula for you. Ignore the negative sign. Do not copy that down. We don't care that it's negative. It's just 6.918%, which would round to what? Perfect. 6.92%.
Basically multiply or divide first?
You subtract first here, and then you would divide. Good? All right, make sure you have this done before you pack up, and then we are finished.